Hi, in this unit we're going to discuss hydraulic and mechanical steering diagnosis. So what can go wrong with steering? A lot, as it turns out. So we can have looseness, wandering instability. This is usually caused by a worn out component. So if you got bad tie rod ends and ball joints and whatever, your steering is not going to be very precise anymore. We can have noises. So noises can be caused by a number of things. You can have belt issues, belt squealing. You can have hydraulic noises from a pump. You can have creaks and groans from seized ball joints or rod ends or strut bearings. You can have noises from the column caused by bearing faults or joint faults, and sometimes even the rubber boot where the column goes through the firewall will cause some noise. It's a number of things there. Pulls. So you can have a pull, either left or right. We want to make sure we're clear on what a pull is. A pull is when the vehicle wants to turn on its own. So if you hold the steering wheel pointed in the right direction, the vehicle will go straight. But if you ease up your grip on the wheel, it will turn on its own. That's a pull. Off-center steering. It's different than a pull. Off-center steering typically indicates a toe issue. But that would be a case where the vehicle is going straight enough, but the steering wheel is pointed in the wrong direction. Instead of like this, it's like this, but the car goes straight. All right. We've got no return or poor return. This is sometimes referred to as memory steer. So that type of problem is typically caused by a seized component as well. Stiff steering or no assist. So if we've got a failure in your assist mechanism, whether it's hydraulic or electrical, the steering is going to feel heavy. Again, also, if we have problems with seized components, the steering is going to be stiff as well. Leaks. So with a hydraulic system, leaks are always a concern. You can get leaks from the rack, from the pumps, from the lines, from the coolers, all kinds of things can develop leaks. Warning lights. So warning lights, typically if you have a warning light on related to steering, it's going to be an electric assist issue. But there are some hydraulic systems as well that have some sensors and control solenoids and things like that will set a trouble code and a fault as well. Vibrations. Most commonly, if you get a vibration in the steering wheel while going down the road, it's more of a wheel balance issue than a steering issue, but customers will complain of vibrating steering wheels. Unequal assist. This can happen on a hydraulic system, but in my experience, it's been more common on an electric system where you have a torque sensor fault that's giving you more assist in one direction than the other. And there's probably more. We'll leave the list there for now. Okay, so what are we working on in the lab? So we've got a hydraulic assisted rack and pinion system in a McPherson strut vehicle and a complaint of stiff steering or no assist. So that could be anything from low tire pressure, fluid leaks, binding components, failed pump, failed rack, any number of things. So our job is going to be to diagnose this. So the scenario we have for you is it arrived at the shop with a complaint of stiff steering. The shop foreman drove the vehicle and confirmed the problem. So it's been confirmed, right? First step in diagnosis. So you have to be you've been instructed to perform a thorough, complete steering inspection and diagnosis, both mechanical and hydraulic. So we'll assume it's the shop foreman's mother-in-law's car. So your professor will identify what vehicle you're working on. So that'll be in the lab set up for you. So you're going to perform a steering system inspection, the same as you've previously done. So you're going to do all the visual checks, look for torn boots, rust coming from components, all that type of thing. Wiggle checks, check the ball joints or looseness, free movement, all that type of thing. Okay, belt condition, fluid level and quality, all that. Right now, because we have a confirmed complaint and the foreman has asked us to be thorough, if we don't find anything, we're going to dig deeper into the problem and confirm the condition of everything. So we're going to start off doing a little bit of an intrusive inspection. So you're going to use a puller to separate the outer rod ends from the knuckles. And you're going to check for free movement of the inner and outer rod ends, free movement of the ball joints and strut bearings on both sides. And then we're going to leave that disconnected. All right. Now, there's something that happens with strut bearings. When we lift the vehicle up, we've got a different situation than we do when the vehicle's on the road. So consider this, right? So we've taken struts apart before. We know that there's a bearing assembly at the top. So we've got a plate here that's attached to the strut, and we've got a plate here that's attached to the car chassis, and then you've got a bearing in here. And that allows the strut to rotate so that you can turn the vehicle left and right. Right? Now, that bearing, typically they function just fine, but if the bearing fails, we can have a problem. Vehicle weight is on that, and it makes it very hard to turn. That may be our problem. Now, the reason we might not find that when we just jack the vehicle up is vehicle weight is now hanging from the strut. So it doesn't even matter if we have a bearing there. Sometimes it will just rotate freely because there's no load on it. Okay, so what we're going to do is we're going to simulate the conditions a vehicle would have on the road. We're going to put a jack underneath, jack up the strut, compress the spring, and that puts weight back on this. So now if that bearing has failed, we will feel that it's very hard to rotate back and forth. So this is what we're going to do. So when we've got the rod ends and wheels still removed, lower the vehicle to about a foot off the floor. You put a floor jack under the lower ball joint and jack it up until you've got the spring compressed. Not completely, but a couple inches. So we've got a good amount of pressure on that bearing. You rotate it left and right to confirm free movement, and then you note your findings. Okay. Now, so here we see we've got the jack underneath the lower ball joint. We've compressed that, and we just turn it back and forth. All right, so that's simple enough. All right, and if we have a seized strut bearing or a bad strut bearing, that will show it up. Now, so make note of everything you found so far. Now we're going to go on to hydraulic inspection. So hydraulic tests we would do, if we think we might have a problem with a hydraulic system. Now we have the gauges installed for you. So if you open up the hood, you're going to find this guy underneath the hood. And this is a fairly comprehensive testing tool here. So we've got a pressure gauge in here, right there, and we've got a flow gauge right there. Okay, so that unit is installed and ready for you to start testing with. So you're going to find your hydraulic tests in the service information. Use ProDemand or ALLDATA, whatever you prefer. You're going to follow this through step by step and record all of your results. Now, I do have to mention something on that pressure gauge. There is a valve at the end of it. You will at some point have to close that valve and make some pressure readings and things. But there is, as a safety concern, do not keep that valve closed for more than 5 seconds. Typically, all you have to do is, everything's running just fine. You close the valve, the pressure reading will change, you record your result, open the valve. As soon as you get the result, open the valve. If we leave that valve closed, we are what's called deadheading the pump. So the pump will generate an extremely high amount of pressure, and potentially that will overheat fluid, cause it to varnish, potentially cause damage to the system. So we don't do that. Close the valve, read it, open the valve, done. Right? You may have to do it multiple times, but every time you do it, close the valve, read it, open the valve. So we always want the flow. We don't want that shut off. Okay, now, so part 7, complete your worksheets. You should be able to ready to describe what your results mean, what specifically has been proven to be good or bad, what would a result higher or lower than what you obtained mean. Find, read, and discuss the symptom chart and the service information. Be prepared to identify what else could cause stiff steering, and discuss your results with your professor. Now, I will note that everything's got to go back together. When you put it back together, that we don't have to do an alignment or anything to this. Your ball joints run on a tapered stud that sit in a tapered knuckle. If you pop them apart correctly with a puller and then reassemble them correctly, everything goes back exactly where it was. So there's no need to do an alignment or anything like that. And provided you use the correct tools and procedures, this is absolutely repeatable. No damage is done, right? And if you're good at it, you can do it fairly quickly. A hydraulic test, by the way, do take time. Okay, that's it. The end. See you in class.